Welcome to The Explainer. So today, we're going to demystify an absolute classic in computer science. We're breaking down a C program line by line. But look, we're not just going to sit here and read code like it's some dry textbook. No way. We're going to treat this script like a physical machine that we are building together from the ground up. We'll see exactly how memory gets manipulated, why C arrays are built the way they are, and how we can literally bend them to our will. So, let's just dive right into it.
We'll be putting this machine together in 4 main steps. First, setting up the blueprint. Second, capturing user input. Third, measuring the word. And finally, the reversal engine loop. Framing it this way really shows that what might look like an intimidating block of code is actually a super logical, easy-to-follow process.
Right here is our master blueprint. It's the complete, fully working C program for reversing a string. Over the next few minutes, we're going to isolate specific lines of this code to see exactly how the software interacts with raw data, working our way straight from the top of the file all the way to the bottom.
Step 1. Setting up the blueprint. Let's look at the raw materials we need for our build.
So right at the very top of our code, you'll see we include studio.h and string.h. I want you to think of these header files as grabbing our essential toolboxes right off the shelf before we even start building. We absolutely need standard input and output, that's studio, for interfacing with the keyboard and the screen. And we've got to have the string library for our memory manipulation. Honestly, without these pre-written toolboxes, our machine just doesn't have the basic wrenches it needs to even turn on.
All right, moving on to step 2, capturing user input. Now that our toolboxes are cracked open, let's see how this machine actually takes in raw material from the user. Right before this intake line, we allocated 100 bytes of memory using char string 100, which is basically preparing 100 empty slots or mailboxes. Then we use this command, scanf. This acts as our main intake valve. It swallows the word you type and drops the letters sequentially right into those slots. Now, quick side note, this basic %s scanf is notoriously unsafe because it doesn't actually check if your word is longer than 100 letters. It's a classic recipe for a buffer overflow. But hey, for our simple machine today, it gets the job done perfectly.
Which brings us to step 3, measuring the word. Before our machine can spit your word out backwards, it has to know exactly where the word stops. I mean, if you only type a 5-letter word, we definitely don't want a computer reading 95 empty memory slots.
So, this is where our machine takes out a literal tape measure. By using stringlen from that string toolbox we grabbed earlier, it calculates the exact length of the word. And here's what's cool. Under the hood, C strings always end with a hidden null terminator, which is basically an invisible 0. Stringlen just walks down the line of letters until it bumps into that 0, and then it stores that final count in our integer variable n. Finally, we're at step 4, the reversal engine loop. With our intake full and our precise measurements locked in, we've reached the dynamic engine of our machine.
And this brings us to a really fascinating question. How do we actually make the computer read backwards? Computers naturally want to process memory areas from the beginning to the end, right? From mailbox 0 down to mailbox 99. So how exactly do we force the machine to reverse its own natural behavior?
Well, our for loop solves this by acting a lot like a factory worker walking backwards down an assembly line. First, we tell a worker to start at the very last character, which is position, n-1. And it's -1 because, remember, in C, arrays are 0 indexed, so we start counting at 0. Second, the worker checks to make sure they haven't walked past the first box, meaning I has to be greater than or equal to 0. Third, they print the letter they're currently standing at. And fourth, that I minus part, that just tells them to take 1 step backwards.
As that loop executes over and over, stepping backward down the line, this printf command acts as the mechanical payload. It literally plucks a single character out of the memory slot our worker is currently standing at, and it displays it on the screen. Because the worker is reading from right to left, the letters print out right to left, and boom, we have successfully reversed our string. So what's the big takeaway from this explainer? It's that mastering these basic mechanical manipulations of memory is the absolute core foundation for building all complex software. We literally just bent the rules of memory to make a computer read backwards. If you can manipulate memory to reverse a word, what else can you force a computer to do? Seriously, the possibilities are endless. Keep that in mind as you continue building and exploring your own code.